Hello, my name is Adam Wynn from Professor Jennifer Earle's Stata Programming class at the School of Sociology at the University of Arizona. And this video is about how to use macros in Stata. So the first question is, what is a macro? Macros are essentially shorthand names that you can assign to almost anything you can type out longhand in a do file. Rather than having to type out or cut and paste elements contained in a macro over and over, you can simply type the macro name and Stata will insert those elements into your code. There are two types of macros, local and global. Local macros only exist for as long as your current program is running, whether that be a whole do file or just a snippet of the do file. They're only going to be defined as long as that program is running. Global macros are saved permanently and can be used across programs, but they should be used with caution because unless they have extraordinarily unique names, they can interfere with do files or just confuse Stata in general. So how do you create a macro? In abstract form, the command for a local macro is local, then the macro name, and then the elements you want contained in the macro. So for instance, we could say local y, the elements we want in that are 1, 2, 3, 4, 5. Now, Stata can recall this number list by simply typing y into your code within a special set of quotation marks, the first of which is found under the tilde key in the top left-hand corner of the keyboard, without shift or anything, and the macro name. You close it with your standard single quotation mark to the left of the enter key. So let's go ahead and put the macro into some code here. Just use a simple display command so you can see that Stata is substituting this number list wherever that y in those quotation marks is found in the code. Go ahead and execute that selection. And we see here display y, and we have our number list. Now, very quickly, there are two sort of special types of macros that we should discuss. First, be scalar, which is just a single digit, any single digit that you'd want to keep around and use over and over again. And scalars can be saved to 16-digit precision, so you get the idea. And then also, R and E class returns are a special type of macro, in a sense. Say if we just go ahead and using the 2012 General Social Survey here, just say we want to progress income on age, or age on income rather. If we just go ahead and type eReturnList afterwards, here we get a list of all of these scalars and macros that Stata is going to save until you run another regress command, and those can also be substituted into the code. Okay, so getting back to some more practical uses for macros. Obviously, you don't just want Stata to be counting for you. One way that this can be very useful is if we have we want to do some nested regression models. So let's go ahead and say that I regress income on a set of work variables that describe the respondent's job. So we'll go ahead and add work status, whether or not they're working, GOVT, whether or not they're a government or a private employee, work self, they're self-employed. Now let's say we also want to go ahead and add some other variables to this. We want to add some education variables, education, and whether or not the respondent has a degree. And let's say we want to go ahead, okay, well, this is getting kind of arduous now. We can go ahead and just cut and paste this maybe. And then we'll add father's education and whether or not he had a degree. And you could see where we could go on and on and on like this. And this is more nested models that I'm creating, the more likely I am to make a mistake, or it's just going to become too time consuming. So what we can do is go ahead and group the variables that we're always going to want, sort of our base variables. We'll just call those work IVs. And then obviously these refer to respondent's education, so we can call those education IVs, and then of course father's education IVs. Alright, and then now all that we would have to do, we wanted to create that series of nested regression models, would be to insert the macro names, where you would normally have to type out everything longhand. Now, where this is going to become particularly useful is maybe I want to add something else to my baseline IVs. I want to add a couple more work IVs. Now, normally I would have to go through and cut and paste those into every single line, but using macros, all that I'd have to do is go ahead and redefine the macro. So let's see here, I'm just looking at the variable list. If we want to go ahead and add WK ageism, whether or not the respondent feels discriminated or against reasons of age at work, and WK racism. Go ahead and add those to the macro. And then I can go ahead and fill out the last line here. And simply add father's education variables. Go ahead and run this whole thing. As you can see in our results window, we now have our nested models. Here at the top with just our baseline work IV, as you can see, we redefined the age macro, or the work macro, I apologize, and those variables are now in every single model. Now, another place where macros are very useful is if you have a standard set of options that you want to use across a series of commands, not a series of commands, but across a series of command lines. Say, for instance, that we want to create a series of uniform graphs, for instance. Okay, let's go ahead and generally make graphs interactively because we can kind of see what they look like. So go ahead and do income and age, and then say we want to change symbols for a scatter plot to hollow small squares and make them khaki because that's a classy color to make our symbols. Okay, so interactively, that was easy enough, but let's say that we want to make a series of graphs. Every single time we'd have to write out this options list or cut and paste it. And more times you're cutting and pasting something, the more prone you are to making a mistake. So let's just say, for instance, go ahead and set a local, just call it OPT for option. And we'll go ahead and place that, the option list, in quotation marks, since it's kind of a long string there. It helps us kind of visualize it. Now, go through and do a series of our scatter plots. Age, income, sex, income, and whether or not the respondent is self-employed, for instance. Now, all that we would need to do, rather than having to type out this big long line, just go ahead, substitute in the option macro that we just made. As we can see, go ahead and run these two together, defining the macro. Then comes up with our set of options. Let's clear this out. Now I'm going to run through where macros become really powerful by demonstrating some simple loops. It often happens that you want to perform the same operation over and over again on a whole list of individual elements, especially when you're recoding multiple variables or adding things in a list-wise fashion throughout a series of commands. Rather than writing out a command line for each element or cutting and pasting tens or hundreds of times, hoping against hope that you don't make a mistake somewhere, the loop command will allow you to put your list in a macro, in a loop-specific macro, and simply substitute the macro name into your code wherever an individual element in your list should appear. So the loop then runs through the command however many times you need it to, substituting the next value or variable, etc. after each repetition. Now there are two commands, but really three types of loops you can use in Stata. The first is a for values command, and that's the first way you can initiate a loop. And this will allow you to create a loop-specific macro with a range of numbers, a structured range of numbers, for instance 1 through 15 in steps of 1, 10 through 100 in steps of 10. For values can really only be used with a specified structured range of numbers, though. And now there are also for each loops. Now for each loops take on two forms. First, they take on the for each in form, after which you can put in unstructured list, maybe a couple of variables that don't really line up in any set way in your data set, or you could put in maybe even some other macros or scalars. Oops, wrong quotation marks. For example, and Stata will just run through those. Now also, the other type of for each command is a for each of command. And you have to give the for each of command a specific kind of list, whether that be a var list, which is going to have to be a set of variables the programmer will break, or a num list, which is going to have to be a set of numbers where the program will break. But just to illustrate exactly what's going on here, let's go ahead and initiate a very simple for values loop. Now, the way that a loop command starts is you have the initiation command, Then we're going to go ahead and type the name we want to assign to our loop-specific macro. So let's just go ahead and call this I for now. And then since this is a for values command, we have to use an equal sign here. And we're going to specify a structured range of numbers. So say we could do 1 through 15. Another way we could write this is 1 and in parentheses 1, 15. This means Stata is going to count from 1 to 15 in steps of 1. This way also allows you to specify steps of 5 or any other number, whereas just doing it that way, Stata is just going to go ahead and count by 1. Now the next step is to open the commands to be looped through with the right-facing curly bracket. And then we're just going to go ahead and use display, and then close the loop by using left-facing curly brackets. So we can go ahead and just run that. And as we can see, Stata has looped through our whole list the first time through, despite 1, and 2, and 3, and 4, and so on and so on. Once again, since we're not just using Stata for counting, let's use go back to the general social survey and look at why you might use something like a for values list. Now we have our age variable, respondents' age, range in age from 18 to 90 plus years old. So let's say that we want to create a separate indicator variable that equals 1 when the respondent is 20 or older, 30 or older, 40 or older, so on and so on. And we could go through one by one and write gen at least 20 equals 0, and then replace at least 20 equals 1 if age is greater than or equal to 20. We could go through and do that for every single value, 20, 30, 40, 50. So let's go ahead and try a for values loop. Call it J this time. We want Stata to go from 20 in steps of 10 to 90, for instance. And we'll open up the loop. And then we can go ahead and generate at least. Go ahead and underscore there. At least J equals 0. Just set that to 0. And then of course we can replace at least J for 1 if age is greater than or equal to J. Go ahead, close the loop. As we can see here, we have new variables created. Alright, so let's go ahead and try a for each loop. Let's say I have a series of variables and I want to center them all on their means, for instance. simple way to do this would just be with a for each, and then we can just call, these are independent variables, we'll just call them x. We'll specify our variable list. Let's say we want to centered versions of the income, years of education, and father's education. Now I want to use, I'm treating this as an unstructured list right now, so we're just going to go ahead and use in there. Open up the bracket, and then I'm going to include one of those R class returns that I talked about later. And the first thing we need to do is summarize the variable in question. And that'll allow Stata to store its mean as this R class return, our mean. So if we want to center each of these variables on its mean, we can first summarize. We can generate name of the variable in our loop specific macro. State is going to be looping through. And call it underscore centered. We'll say that equals given variable that Stata is looping through at the time minus its R class return mean, which is going to be taken from summarize each time through the loop. So we can go ahead, just close that there. Execute the selection. And see that each time Stata has summarized and then generated us a centered variable over here. Now, generally, when you're just getting started with loops, it's easier to just use the for each in specification, as the program is not going to break if you don't give Stata an element that it's not looking for. One example where you might want to use a more structured list, I'm going to go ahead here and load the National Organization Survey from 2002. The thing about this data set is it has a lot of unique missing variables. They're all coded as negative numbers. So on each question, like for instance, question 2, whether or not the organization is public or private, all missings are quoted as -3. And that can really create some problems if you're going to be running some regression analyses and these things, or if you're not really concerned with the unique missing values. So what I could do is I could go ahead and go through one by one and generate Q1A dot. Don't want to overwrite the variable because we're not sure, we wouldn't be sure then if it actually transferred over correctly. So it's Q1A if Q1A greater than or equal to 0. I can go ahead and I can go through and do this. The problem here is that this data set has 163 questions. Most of them have at least 2, if not 4 or 5 parts, so it would end up taking 363 lines of code, more or less, to do this one by one. However, can really expedite this process with a structured for each loop. So we're going to go ahead and type for each, and then we're going to call our loop specific macro var, because this is going to be a variable list that we're going to give it. Now we're using of instead of in for each var of. The thing about this structured list is that you don't have to go ahead and paste in all 363 variables, because then even the loop starts looking messy. What you can do is see here that the questions really start at Q1A, they end Q163, and then you have everything in between, and that's how the data set is read. So we can go ahead and define our var list as Q1A through Q163. Open up our brackets. And then generate name the variable dot, since we want to replace the unique missing values with dot missings. That's going to equal the variable name if that specific variable state is not looping through at the time. It's greater than or equal to 0, since all of the missing values in this data set are coded as negative numbers. Alright, well that's good and fine. Now we need a way to ensure that we are changing things a way that we can check up on. So we can go ahead and tabulate the new variables that we're creating. And the original variable. And we'll just go ahead and look at those missing values, since those are the only values from the original variable that we're operating on. Go ahead and add the missing option to the tabulate. You can close that. Run this. Generally, when we're using a loop, we're going to want to use the unstructured for each in call. But this is a situation where we might want to use the for each of, and then give Stata a structured list to look at. This is the National Organization Survey from 2002. As you can see here, it has 163 questions. A lot of them have 3 or 4 parts, so there's 363 variables here. And all of them have unique missing values that are coded as negative numbers, and that can really become a problem if we're running regression analyses or something like that on any of the variables. Now we could go through and once again type them one by one and check them against the original variable, generate Q1A equals Q1A if Q1A is not equal. You can go over and over and over again. However, a much easier way to do this would be just to simply state a for each command. Now, we're going to give Stata a var list, so it makes sense just to call our loop specific macro here var, and then to use of. Now, when defining our var list, we can see here that all the variables are structured Q1A to Q163. That's the order they've been read in. So rather than having to type out all the variable names and maybe forgetting some or cutting and pasting them wrong. Giving Stata a structured list, you can simply tell it to go through the variable list in order from Q1A to Q163. Now here, each time we're going to generate call this var dot because we want to replace the unique missing value with just simple dot missing. So we'll just generate a variable called var dot. Make that equal to the variable. Perhaps we even want to save the value labels so we can tell exactly what these new variables are. So we'll just use the clone variable command in that sense. Now all we have to do if we want to replace all of our unique missings, dot missings, is replace var dot, which is the new variable we're creating, equals dot if original variable is less than 0, since we know all of our unique missings are negative numbers. Now we should also go ahead and check each one of these. We require creating an awful lot of tables if we're doing this line by line. There already would be over 700 lines of code here. So just go ahead and tabulate the existing variable, the one that the state is going to be looping through, along with our newly created variable. Now we'll go ahead and restrict that to cases that we actually operated on, to those in which the original variable equals less than 0. And then we'll go ahead and add the missing option so we can make sure that we can see those. Go ahead and close the brackets there. Small mistake there, and just need to put space in there. And here we can see all the unique missings and all 363 of those variables been translated to dots in a matter of seconds. So hopefully this introduction to macros and simple loops will convince you to incorporate more automation into your own work. Saves us an awful lot of frustration and typing that can really get in the way of our substantive thinking process when we're programming. So thank you for watching, and one of my colleagues will be covering some more complex loops.